Hello everybody. In this question basically a system is given. It consists of a rod which doesn't contain any weight of length L. This one. At point A, it is hinged and a load of mass small m is on its other end. ठीक? Now it touches a body of capital mass m. It means that they are touching each other. Now this is its initial position. Now if a light jerk is provided to this system, then this system came into motion. Then when this rod make angle alpha, which is equal to pi by 6, then at this instant we have to calculate two things. First of all, we have to calculate the ratio of their masses, and second, we have to calculate the velocity of the body. So basically what I am trying to say, that if we if at its initial position, this, okay, let's hide this. So this is point A. Now this is small mass m. It is connected with a body of capital mass m. So this is its initial position. We say that this is time equal to 0. Okay, please forgive for my drawing. This is small mass n or load. Now this, we know that this is hinged. This rod of length L is hinged at point A. So it cannot move linearly. It only can move in circular way, like this. So it at any intermediate time t is equal to any intermediate time, t is equal to t1, it came into that position. Now at this moment, this mass will move to a certain distance. Assume that this is x. This mass is in this body of mass capital M move in linear motion or translation motion, but this hinged rod move in rotational motion or circular motion. So after any instant t is equal to, assume that t is equal to t time period, just taking the time period, when its angle will be just alpha. So assume that this is in circular motion. Now this is angle alpha. At this motion, at this point, these bodies are still connected but moving in like this. Just say that at t is equal to next instant t is equal to t plus. This angle is also alpha at t plus, just in order to make you visible. I am showing this, but this is not such a distance. If this is, we calculate x1, then it also move like x2. So this is also x2 only, but I am showing this because they both are do not linked with each other, or they are separated with certain distance. Now at this point we know that if we do this, then just I am taking free body diagram of these both figures. So this will be like this, and just for the visibility I am taking it as like this, or be at some distance, capital M. Now it is in circular motion, so its velocity is always tangential to it, that its velocity will be v. Therefore it has two component. If we decompose, just taking it alpha, so this will have two component, vx and vy. So this is equal to vx, and this velocity of this body will be u, as it is given in the question. So I want to state that vx is equal to u. Similarly, this will have two acceleration, or I will draw it separately, just there. I want to state that at this, I am just showing the acceleration for this. This is tangential acceleration at, and this is radial acceleration or normal acceleration. So this is radial acceleration or normal acceleration, and body of mass m is moving with acceleration a. Assume that this is moving with acceleration a. Now its radial its horizontal component of acceleration, if we assume that horizontal component of acceleration of this body which is in circular motion is ax, then ax is equal to a. So how I am going to calculate ax? Okay, I will draw in taking next page. So basically drawing this figure. So this is alpha. Now this will be acceleration due to gravity. Now this is a radial acceleration, and this is tangential acceleration. This is alpha. So therefore we can say that this is pi by 2, so this angle will be pi by 2 minus alpha. So and we know that angle between radial and tangential acceleration is equal to pi by 2, so this angle is equal to alpha, and these both are alternate opposite angles, so this will also alpha, and this is alpha, so this will be pi by 2 minus alpha. Now if we divide tangential component into its two component, horizontal and vertical, then this must be 80 sine alpha, and this will be radial, AR cos alpha. And if we decompose, this is also angle alpha, so if we decompose the value of G, then its value of G along 80 will be 80 is equal to G cos alpha, first equation. Now if we calculate, and there is our body of mass m, capital mass M, sorry, just I will erase it. So of capital mass M, it is moving with acceleration a. So we know that acceleration a is equal to horizontal component of acceleration of the body in circular motion. Therefore a is equal to 80 sine alpha minus AR cos alpha. So just I am removing the background. Now this is equation second. Now we know that radial component in circular motion is always equal to velocity square over radius of the circular motion, and in this case the radius is equal to L. Therefore AR is equal to V square by L. Therefore acceleration is equal to, putting value of 80 in this equation, or just we say that putting equation first into equation second, therefore acceleration A is equal to G cos alpha sin alpha minus V square by L cos alpha. And we know that just in order to make you understand that I am telling for this velocity V, or I am indicating this V as this one. So now acceleration A is equal to this one. So this is our third equation. Now if we take the free body diagram of the figure in which just I am drawing, this is okay. Just please ignore my drawing. So this is capital mass M, or just more easy to make you understand that, assume that it is capital making a free body diagram. Now there is a normal force due to the circular motion or pushing due to small mass m. There is a weight force mg, and it is moving with acceleration a. Now if we taking the horizontal component then and applying Newton's second law, applying Newton's second law, then acceleration a is equal to m a is equal to n. Therefore just now rewriting the expression, n is equal to ma. Okay, assume that it is equation 4th. Now at this instant t is equal to t positive, this n is equal to 0, but acceleration remains same because it is next instant. So m a is equal to 0. Now putting value of acceleration in this equation 5th, therefore m and previous acceleration, which is g cos alpha sin alpha, g cos alpha sin alpha minus v square by l cos alpha equal to 0. Therefore this m get cancelled, cos and cos get cancelled, therefore g sin alpha is equal to v square by l. Therefore v is equal to under root gl sin alpha. Now we have to calculate the value of u, as we know that, and u is equal to velocity in x component, not v. But this thing we have to take in our understanding, otherwise we will make some mistake. Now we know that v is like this and this is alpha, therefore this is velocity of x. Now this we know that this will be pi by 2 minus alpha, therefore value of u is equal to vx is equal to under root gl sin alpha into sine alpha. Therefore, our one part of the question is calculated. Now we have to calculate ratio of the masses. Therefore, for this we apply conservation of mechanical energy. Therefore, first of all, we have to understand that at initial condition, this will be length L. This is also alpha. So this is also L. So L sine alpha. Therefore, if we calculate this much, assume that this is y. Therefore, y is equal to L minus L sine alpha. Therefore, if we assume both cases, first initial condition and at time t is equal to 0 and time t is equal to capital T, then potential energy initial plus kinetic energy initial is equal to potential energy final plus kinetic energy final. Therefore, potential energy initial is m g L minus or mg y, L minus L sine alpha plus kinetic energy 0 is there. Now potential energy final is 0 plus potential or kinetic energy is half small m v square plus half capital M into u square. Therefore, mg L 1 minus sine alpha is equal to, or we can say that, half m v square, and we know that from previous value v square is 2gl sine alpha, is just gl sine alpha plus half m, and value of u will be this one. Therefore, it comes gl sine alpha into sine square alpha. Now we have to calculate at specific angle alpha is equal to pi by 6 or 30 degree. Therefore, mgl 1 minus 1 by 2, 1 minus 1 by 2, and this will be 1 by 2 m gl into 1 by 2 plus 1 by 2 mass gl into 1 by 2, or this is 1 by 4, this is 1 by 8. Therefore, this will be mgl by 2 is equal to 1 by 2 mgl into 1 by 2, and this will be 1 by 2 mgl into 1 by 8. So 1 by 2, 1 by 2, and this 2 will get cancelled. Now G and L also get cancelled. Therefore, if we go on, so So from previous there is m equal to half m by 2 plus capital M by 8, m by 8 here, m by 8. So this will be m by 2 is equal to m by 8. If we cancel m by 4, therefore mass by m ratio will be 4. Similarly, if we calculate u at angle alpha is equal to pi by 6, which will be under root gl into sine alpha pi by 2, and there is also 1 by 2, therefore 1 by 2 root gl by 2. This will be the answer. Thank you. Thanks a lot.